Okay. This is 8.2 homework questions here. We're at 39. So 3 plus 3i. So write each complex form in trigonometric, write each complex number in trigonometric form, do it in degrees, and then also do it in radians. In each case, begin by sketching the graph to help find the theta. So if I'm going to sketch the graph real quick here, and this one should be pretty easy. In fact, I think we can probably even do it without having to do all the work. If you go up, if you go sideways 3 and up 3, what degree angle is that? Yeah, it's 45 degrees. I know that already right away. So the only thing I really need to find is the R value, which is 3 squared plus 3 squared. So 9, sorry, 18. Awesome. And then complex number?
You just have 3 or 2 CIS.
3 or 2. CIS 45 degrees. And now let's convert that to radian now. 3 or 2. 5 or 4. Good by me. Think we're good there. Are we good?
Was 35 the same kind of problem? Because I just have a graph.
35, yeah, except your angle's gonna be different, but it's still a multiple of a 45-degree angle. You want to see 35 real quick here?
Because I think I want the graph to I just have a straight line on the x.
Oh, okay. So it's 35 is -1 plus I.
So I thought, oh, okay, so it would just be -1, 1.
43 would be a straight line. Yeah. 43, that would be -9 is the problem.
So for these ones, you're looking for a reference angle?
Kind of.
I thought it was the positive x-axis. Put -1, 1 be 135.
Ooh, interesting. Let's check it out.
I couldn't remember if you were going. So it is. It's not. It's not.
8.2.
Yeah.
Number
It's here.
35. So 135 degrees. So positive x-axis.
Nearest to the positive.
Basically, if you're above.
Oh, I'm wrong. I'm wrong in my drawing. -9 would be this way, right? And 9 units away.
Oh, yes.
So away from the positive x-axis, that would be in degree term. So theta is equal to 180 degrees.
Oh, that was easy. It's just
81, 82, right? 9 to the first one. Or 0, 0. So it's just 9.
9. So 9. CIS 180 degrees. 9 CIS pi would be it. Let me just check. Make sure I'm correct. And 9 CIS pi. Okay, cool. And they also give you the long version as well, right? They give you 9 parentheses cosine. So they give you the long version. They give you the 2 short versions. They give you the long version with the degrees only. I'm not sure why they do that. And then they give you the short version with degrees, and then they give you the short version with theta, with radian measure.
You're gonna do the short version. We have a long one, so you can check it. So you can just substitute pi for 180 or whatever.
Yeah. I figured as much as well. Yeah. Figure out how the book's thinking. Okay, 51. 51. Write each complex number in trigonometric form. Round all angles to the nearest 100th of a degree. So as soon as I see that, I'm thinking calculator.
This one confused me because the answer was bigger than 180, and I thought the angle was always going to the nearest. It's the fastest.
Okay, yeah. Let's see, I'm kind of flipping between that and that. So let me.
I got like 286.3.
If that's if you're going all the way this way, you're gonna have to go this way to get back.
Yeah, but it's above 180 though. Let me see. Maybe I am confused a little bit here. Let me go back to where it talks about theta. So complex numbers, and then we moved on to trigonometric form over here. All right, so I need a theta that goes like this, right here. So at this point, the best way to do it is just to say theta, tangent of theta is the y value over the x value, except what we're going to do is we're going to keep it positive. So why do we want to keep it positive? Because it just gives us the reference angle in quadrant 1. And that's cool. So theta is going to give us tangent inverse of 24/7. And anybody give me that guy?
73.739.
73.739. So 73.7.
Yeah.
Okay. Okay.
73.74. Yeah.
74. Thank you. 7.4. Okay, so that's going to give me, let me do this in blue. So that's going to give me a reference angle. 73.74. Perfecto. Okay, so if that's the case, let me draw it just so it's a little bit. That's 73 would be like right there. That's 73. 74. Okay, so we flip it across here. If we make it here, that's going to be 360 subtracted from 73.74. So tell me if that's correct.
Yeah, that's 286.26.
Okay, perfect. We've got our angle measurement. That's awesome. Now we just need to get our R value. R value is going to be
27.
perfect. Yes, there is. Yeah, and then there's a whole thing about what gives us integer values and what gives us root values that we can find, and then what, yeah, it's a whole. I think it's been a whole semester just dealing with that. Okay, it's gonna be 25. So final answer is
25 CIS 286.26.
Do we need to do this in radians too? Because that sounds long.
let's see. No, 100th of a degree.
Okay, cool. That's better.
Okay, now we got the 55, 59,
55. Whoops, I did 55.
59, and what would be the correct, if we were going,
55, 57, 55, 59, and 63.
oh no, because we only got to 61. So I think 57 would have been the only, right? You guys, 57 would be the only every other odd problem.
So we were at 51, so it'd be 51, 55, 59.
Oh, interesting.
But I
Yeah,
think-
yeah.
Oh, gotcha, because we start at 7.
Yeah, we started at 7 instead of
Because you go
1.
159 and then 37,
Yeah.
and then 159 and then 37.
Okay, gotcha. So 55 is correct, 55, 59 is correct?
Yes, 55. 59, yeah.
Okay, it says, so for 55, it says go back to 47. Use the graphing calculator to convert the complex number to trigonometric form in the problem below. So from problem
The problem
57.
is, number 47 was just converting the standard form to trigonometric form. So what's the point of doing it on graphing calculator? Because I already have an answer. Yeah.
No, ain't that just fun? So let's go with it here. So you guys have your calculators with you?
Yeah.
Cool. I'm gonna jump to mine. No. And let's see. Let me see. We didn't do it in class here. Let me just check out something real quickly here. Class, for now, let's see, for now, I think we can skip those. Can we skip those for now? We'll get to them a little bit later. I figure this would be,
I tried skipping one.
yep, please do. Okay, we're good there now? Dylan, we're good, we're gonna skip those? Okay,
Well, for me, I know you voted against that.
no, not at all. If we skip, we skip.
Price being 61.
Mhm. Yeah, skip the rest of those, the rest of it. I wanted to do the calculator stuff later, that was leftovers. All right, we're jamming, where are we jamming? We're jamming with the rest of 6.3.
8 point, I don't know why.
8.3, 6.3.
Yeah, I mean, the step is 6, 7, 9, you know, it's fine.
So we are multiplying stuff together. We found out all we got to do is in trigonometric form. It is so much easier to do that. And so all we got to do is multiply
So handy.
the R values together, add the angle measurements together, and done. Love it. Okay, so now we did this one right here. Then the previous one, that's cool. We could, time remaining here, I think we probably should just move on with the formula first. So now the question is this, what happens if you take powers of something?
Oh,
Oh, crazy.
Well, squared is the same thing, but I don't even want
didn't we just end up deriving R1, R2, CIS if they want?
Yeah, so that's the multiplication problem. And so if we look at the title for 8.3, we have products here. We also have quotients. No, products and quotients. We have the divide as well. Oh, man. I wish the title said products, comma, exponents, comma, and
But it's not what we
quotients. Say again?
The exponents are products technically, but. they're just,
True.
You know, special.
It's a
Mhm.
lazy way to talk about this.
Well, it's a good thing with notation, but I can imagine writing it 10 times, like, you know, 3.75 times 10 to the negative 15, like, ouch,
Mhm.
that'd be awful.
So there's,
Negative 15, that's just even worse.
so there's a person called, his last name is Demoivier, first name Abraham. Hey, all right, that's cool. So what he figures out is, okay, so we do products, right? And Isabel just said, products are the same thing as multiplication, you just do it, keep on doing over and over and over again. Okay, let's see. If I keep on doing this over and over again, but whenever I take exponents of stuff, does that mean that I'm multiplying the same thing over and over again? Okay, so let's do this. I think we could do this. We're smart enough. So, example, I'm going to multiply 3. I'm just randomly pulling this out of my brain. You guys talk to me here. What happens when I do this? Should be really super easy. Answer is
9 CIS 20.
9 CIS 20.
Multiplied by 3 CIS 10 again.
Thank you.
You're at 27 CIS 30.
Boom. 27. Oh, that is so cool. This is 30, right? Okay.
So like 3 CIS 10 to the second or third. We just do 3 in the third and then 10 3 times.
Sweet. Okay. So give me this one here off to the side. CIS 10 to the 5th power.
Let's see, it's 50. You know,
243 CIS.
Gonna write.
3 to the 5th power, just checking Asian multiplication.
243.
Didn't even need a calculator.
43,
Mental math.
If you're good at mental math, which I
CIS.
am not.
50. Are we good? Dude, so this is just product, really, the multiplication rule, exponent rule, really just the product rule multiple
Didn't
times.
we do that when we did the sum formulas too? Because there was the sum of the way, it's the same thing, we just have the same.
Same thing, yeah, and then add the same thing over. Cool, okay, so let's go with formula here. So if this guy is, oh, of course, and actually, the guy named it after himself. Actually, I should look it up if he named it after himself or someone did in de Moivre's theorem. It actually becomes a theorem. In 1772, he publishes a formula. Okay, de Moivre's theorem have this z, because that's what we call these guys here, z to the n is equal to r cis theta. Everybody okay there? To the n power? What gives us, or actually I can put it over here, which will equal r to the nth power cis theta times n. I think it's n times theta, just right there, but same thing. There it is. Awesome. So let's do one example there, and then we'll start dividing the stuff.
That's actually so easy.
Yeah, that's nice.
Of course, but I'm going to give it to you in a very not so nice form, because
Oh,
just to torture you a little bit here.
If you write it in XY form, I will not be happy.
Please find
At
for
all.
me.
Yes, it is.
Yeah, of course you guessed it, because that would be the torture form. I need this guy.
But you have to put it into the other thing.
Mhm.
Oh, to the 10, okay.
Which is root 2 CIS. So it's actually really easy. Okay.
Root 2 to the 10. Don't miscalculate. Don't perform this alone.
Can I write 450 degrees? Or should can I write that it's 450 degrees, Mr. Henry? Or should I,
450 or 45?
well, it's 45 times 10.
Oh, got it. So when you pass it up, you're going to subtract the 360 from
Okay,
it.
good. Okay.
And then notice you started off in an a plus bi form, right? So when you finish it off, it has to be back in the same form.
Oh.
You sure
So-
about that?
Unless you want to do 1 plus I to the 10th, 1 plus I times 1 plus I
I'd be fine
times 1
keeping
plus
it
I
like this.
times 1 plus I.
Actually, typically speaking,
So you guys talk to me.
On our calculator somewhere.
90.
1 plus I, you're everybody okay with the square root of 2 as being the R value? You guys talk to me. You good there?
Oh, hold up.
CIS and 45 degrees. Everybody good there? Dylan, everybody good?
That's just without 2 times.
Yeah, that's just the unit value itself. And let's go to the square root of 2.
It's just gonna be 2 to the 5th instead of root 2 to the 10th. So it's gonna be 32 on CIS for 50.
Perfect.
90.
It's this to the 10th. CIS to the 450, which really just becomes 2 to the 5th. CIS 90, which becomes 32, right? That's it, it's 32. Oh, no, 32 CIS 90. Now, can you guys convert this back to?
Well, I just calculated it by 1 plus I
I don't
to 10
remember
power.
how to convert that. How do you convert that?
That is a very good question, but if I calculate, if I plug this in right, I can get 32I. Which I feel like I kind of do, because that doesn't sound right.
Hold on, so 90 degrees, where's 90 degrees?
It's just gonna be 0, 1.
I'm right.
It's here,
You're
all right?
Yay.
So horizontal, the real number system, we don't move anywhere, right?
We don't even need the R.
We just move up the imaginary number system, 32 degree or 32 units. So 32I, guys, that is super, super lot
Actually, never need
faster
to go that way.
than,
Wait, so for this, when you're converting trigonometric form back to standard form, you just take the degree, that gets you the A and B values, and then the R is just multiplied through those.
yes. Absolutely, it's a lot easier to go that way. Okay, so we got taken powers, and with the time remaining, let's do division. And so,
It just stays in power.
I don't know.
Like that.
We could do the same proof that we did before. It just goes in reverse. Or I could give you the formula here. So the theorem, division theorem.
We should go.
Am I allowed to use my calculator to do that now, or we should try to say no?
Can you use your calculator? But too short. Oh, that's me. Okay. All right. Let's go with same thing. Yeah, Z1 divided by Z2 will equal R1 CIS theta 1, R2 CIS theta 2, and you can kind of guess here. We were multiplying these guys together. We multiplied the R and we added theta. Therefore, we are going to divide the two R's and
Oh, I see.
subtract theta. Are we good there?
Oh, okay, that's not too bad.
I still like this one better.
Yeah. Should be cool. Okay, this is a problem.
Find the quotient of 20. CIS 75 degrees and 4. Not bad, not bad. Okay, all yours. Done. Are we done?
Yeah.
35 degrees. Okay, are we good there? Okay. Then we have exercise 6. Oh, this would be fun. Let's see, 1, 2, 3, 4.
That evil smile.
Do you know how this one right here, we converted from that to trigonometric form, did the work in trigonometric form, converted it back? Well, for the division one, sometimes it's easier, sometimes not. It just kind of depends on what happens here. So in this case, can you divide? Divide Z1, which is 1 plus I root 3, and Z2 root 3 plus I. So let's do this here. You guys ready? I'm gonna do Dylan, Abe, and Isabel. You guys are going to put into trig form and do the work there. Tristan, Dylan, Max, and Natali, you guys are just going to divide it out. What would you guys have to do here to do something? Something will rationalize their denominator. What would you multiply by to rationalize the denominator? Yeah, Tom. Oh, cool. Yeah, so close here. Reverse or it's the complex conjugate. Complex conjugate means getting this. Oh, no, that might be J. Real number stays the same. Opposite of the complex number. We good? So Dylan, Abe, and Isabel, all yours here. Converting is
Convert equals 2 CIS 63.
2 CIS. How did you get it so fast?
Just the tangent inverse of root 3 over 1 equals 60. And root 3 squared is 3, 1 squared is 1, and 2 plus 1 is 4, and root 4 is 2.
Is that the first one?
Yeah. And for the second one, it's just,
This one is what right here?
that one should be 1 over root 3 tangent inverse, it's going to be 30. And then you throw that 2, so that's 30. And then if you like dividing something like
That's
2 divided by 2 is 1.
CIS,
There's just, yeah.
And then converting it back.
and 30 would be the same one as the first one, so root 3 plus I. Oh, wait, no. The two's gone.
The 2 is gone.
So it's just root 2 plus 1/2 I.
Cool, okay. Makes sense, guys, hopefully. This one right
I
here.
don't want to do it that way.
Okay, this one is, let's go with this one here. Let's see, this is gonna be, that's gonna be 3. 3 minus 1 makes a 2. Now I know where the 2 comes from. So 2 is on the bottom. That's gonna be a root 3. That's gonna be a minus I plus 3I. Is that plus 3I? And then this one's going to be negative root 3, so it'd be a plus root 3. Okay, everybody good there. Oh, sorry. Yeah, go ahead.
That doesn't simplify right, does it?
No, because this guy should be a plus. There you go. That should be a 4. True. Because a negative I times I is a negative I squared. Becomes negative of -1, becomes a +1, becomes 4. Okay, that's a 4 on the bottom there.
Oh, then that
So I
makes
get
sense because you have
2
2
root
root 3 plus 2i.
4 plus 2I over 4.
Which is root 3 over 2 plus 1/2. That's
Done. We good, guys?
Wait, can you just? You're just adding them?
Sorry, guys. Let me take this off. So I'm just trying to. Good.
So just do the difference of 2 squared and the bottom. You get rid
I
of
mean,
the
like rationalizing any denominator, because I in this case just functions as a variable until you have I squared.
Yeah.
Okay. You guys talk to me. Are we good? So this one with the division, you could probably do one or the other. With exponents, definitely use trigonometric form because you don't want to be multiplying these out all the time, again and again and again. With the products, same thing here. You could probably do one or the other. Cool. All right, we are done. 8.3. End
Can I
here.
assume that I